Before your break, we were looking at fossils, and the reason we were looking at fossils was because we were answering the question, what is the most compelling form of evidence for evolution? And we said that fossils, they're there, they're in front of you, they're tangible, you can touch them, you can dig them out, or you can view them in amber, for example, but the fossils are there. Other evidence must exist for evolution, and so we're going to now spend a little bit of time looking at other compelling evidence that supports the theory of evolution. One thing that we can look at is the idea of homologous structures and analogous structures. And what do we mean by this? Well, homologous structures are often referred to when we speak about divergent evolution, whereas analogous structures refer to convergent evolution. So what we mean by divergent evolution is two lines, or one line that has a common ancestor that diverges. Convergent evolution means that we find different structures from different lines. We've got different lines of evolution, but they have no common ancestor, all right? But they arrive at possessing a structure that is similar. So we said homologous, there is definitely a common ancestor. Analogous structures, no common ancestor. These are separate lines of evolution. And homologous structures do not always have the same function, whereas analogous structures always have the same function. Homologous structures will have the same or very similar basic structure, but analogous structures will have different basic structures. Now, I've given you a lot of theory here, and I think what is important is that you're able to relate this theory to some concrete examples. So, as an example of a homologous structure, let's look at the forelimb of a number of different vertebrates. Your arm is a forelimb. So here we've got the human arm, and you're familiar with the structure of it. You have a humerus, a radius, and an ulna, bones forming your wrist, which are your carpals, bones forming your hand, which are your metacarpals, and the bones of your fingers, which are your phalanges. Now, can we find, if we look at other vertebrates, can we find a similar structure in the forelimb? Well, here's the forelimb of a whale, and you can see that we've done the same color coding for those different groups of bones. Here we find the forelimb, or the front leg, of a horse, a lion, a bat, and a bird. And you can see that even though these structures are used for very different functions, swimming, running, and using those formidable claws to subdue prey, basically tool usage, and flying, we can see that they have a very similar underlying structure. So if we go back to this slide and we look at our table, we see that there is a common ancestor when we're talking about the evolution of vertebrates. We can see that that forelimb does not always have the same function, but we can see that there is a similar basic structure that underlies the development of that organ. If we look at analogous structures, for example, eyes, we can see that vertebrates, like this cat, has an eye, the insect has an eye, and the mollusk, which in this case is a squid, has an eye. In no way do these organisms, let's go back to this table again, have a common ancestor. There's no common ancestor here that is producing this eye, but they always have the same structure, and that is to see. They always have the same function, and that is to see, but they have very different basic structures. The eye of the insect is made up of all those tiny little components called ommatidia that all work together to create a mosaic appearance. Other analogous structures, we see the wing of a bat and the wing of an insect, both there for flying. Same basic function, but a very, very different structure. The streamlined shape of a shark and the streamlined shape of a dolphin, once again, the same function to get the animal through the water at very rapid speeds, but they are produced in different ways. Vestigial structures, another compelling form of evidence for evolution, where you will find hind limbs of snakes and whales, nictitating membranes in humans, the small little dew claws of mammals, and of course your appendix, all structures that have become smaller and smaller and smaller over time, but they do indicate that there was once a use for such a structure. I'll see you again after the break.